Okay, so I realized the mistake we were doing yesterday. Okay, so see, Gini index is only used to um, select which one to go for, right?
So
But
you're not sharing any screen
yeah.
as of now.
Yeah, yes.
Okay.
I'm looking for the share question. So, okay, Gini index will only tell us, okay, which one to select, okay. So,
Okay.
because this has the weight had the lowest Gini index, so we selected weight, right?
Yes, sir.
But to calculate, we have to look at the error, okay. So again, if you see the, I think, see if I have opened this PDF. You may not be able to see. Do you see my PDF? No, right?
No, sir.
Yes. Karthik is here. Hi, Karthik.
Sir, good morning, sir.
Very good morning. So we are in classification, Karthik. Okay. So yes. So see here, it says 1 minus total error by total error. Okay. And your total error is what here? One by 8, isn't it? One error out of 8. You see that? You see my PDF?
Yes, sir. Yes, sir. Yeah, we can see, sir.
All right. So we had here, okay, in yes, we had 0 in error, and in no, we had 1 error. So 1 by 8. So it becomes 1 by 2 log of 1 minus 1 by 8 by 1 by 8.
Okay.
Okay. So 7 by 8 by 1 by 8, which is 7 by 1,
Yeah.
log 7. Okay.
Yes.
So now if we put log 7, it's so you get 8,4. Now we divide by 2, half, isn't it?
Yeah.
So this by 2. Okay, you get 4,2. Right. So that's all. So okay, and okay, so this becomes here it became 0.33. Okay, and okay, now so this was the previous value. We added a sample weight. Okay, new weight, okay, is, how did we calculate new weight here? Okay, so coming back to our here, okay, so this is 1 by 8 first weight. Okay, your new weight is going to be sample weight. Okay, this is okay, old weight, right? New weight is old weight, okay, into e to the power, okay, into e to the power we had let's first calculate step by step. Okay, so your new sample weight is going to be e to the power of, okay, e to the power of amount of say. Okay, okay, now we have to find e, that is exponent. Okay, e raised to the power exponent of, okay, and minus, and what was it, 0.88, right? 0.88, right? The one that we got log of error. So this is 0.4 and the old weight is 0.24 here, right? Okay. Okay. So for each of these, okay, you have to calculate the new weight. So see, this is where we were struggling, right? So this is, where did I go wrong here? Hold on. Okay, but before we look into this, you see here, okay, which has correctly classified the values? Yes, yes, right? Weight, yes, yes, right? So your weight, okay, so these are all more than 175, right? If you see, these should have, okay, one weight, and can you see which is correctly classified here? Chest pain, yes, yes, right?
Yes, yes. One.
Chest pain, yes, yes, and blocked artery is 50-50%, right? That's why I got Gini index 50% here. Okay, higher, see, lower the value, more accurate is the result, right?
Yes,
So
sir.
when we pass to the next, row or next tree, we have to give more weightage to the lower Gini index value,
Yeah.
right? So
I think we have gone wrong in calculating the amount of say, sir.
Gini index is correct. Okay.
Yeah. This amount of say, the formula only I have doubt.
So see, if we do log of Okay, but we are doing log of 1 minus 1 by 8
Yeah,
divided by
1 by 8.
1 by 8. Okay.
Yeah.
Okay, it is, I think, not E, it is log, this is log base 10, is it? Log, no. So
Ma, document
this is log 10. Now for it says, so see, amount of say we are getting 88, that's what I was doing, 84. It is getting 0.97.
Yes, sir.
It's getting 0.97. Eight minus 1, 7. It is log 7 only, right? It cannot be anything else. 0.84. Okay. Mm. No, the amount of say is half of this. It's not even 97. Okay. By total. Okay, I think, you know what?
Maybe the log is for only numerators, sir.
No, no, no. It cannot be for numerator. It is for the entire thing.
Okay.
So now if you see here, amount of say, let's say if amount of say is also minus 9.97, we get 0.33. Okay. So 0.33 is for, okay, this is the wrong one, right? This is the error. Okay,
Yeah.
this is the error. So it is like saying, see, I'm not been able to classify this correctly. Okay, and I've been able to classify rest correctly, except this, because here you have one error, right? So if you have one error here, we are saying that this one, okay, rest is fine. See, when you're passing right, you have to tell that this question you have to address,
Yeah.
right? And then rest is 0.05. Okay, 0.05 because the amount of this is 0.1 by 8 into 0.3, so 0.05. Okay, and this is e to power 97.3. So this I understood here. Okay. So this is 1 by 8 into e power 0.97 and e power minus 97. This one I forgot what I did then. Total number is 1/8, amount of say is 0.97. So see, because Gini index is weight, we have taken weight and heart disease. Okay, so this we know so far. Now in this case, okay, whichever you have classified wrongly, this is what we have classified wrongly.
Yes,
correct?
sir.
So
Less
this,
than 175.
yes.
Yes.
So this has to get higher weight, right? This has to get higher. That since I'm not able to find this, okay, since I'm not able to find this, you please work on it. And rest of the things, because you have correctly classified, it will have less weightage, or no, it's not totally zero, but you'll have less weightage because you still would see, right? If I tell you, see, out of 10 questions, I have 9 questions I have solved it. 10th question I could not solve it. So you will spend more time on 10th question,
Yeah.
isn't it?
Yes,
And you'll
sir.
spend less time on this question. So that is clear. But I'm not able to get this say, okay? Say we are getting 8.4 and
Yeah.
this fellow is getting 9.7.
Yes.
So even let's say we go with 8.4, let's say, okay? If you go with 8.4, so the wrongly classified, okay, will be e to the power, okay, this one, and this divided by 2, right? Half. So 1.16. Okay. No, sorry, not 1.16. By 8, right? We have 8 values total. So you get 0.09 or 0.3. So weight of this is going to be 0.3. Okay. Okay, for a minute, let's forget this 97. Let's go with what we have calculated, 84. So this one is incorrect. So you will go with 0.3. Now for next one, what we'll do is we will do e to the power of this one, which is minus, right? So minus, okay. So this is 0.05. Okay. So this will be 0.05. Okay. Everything else is correct. So this value will be same. Okay. All the incorrect ones will get 0.03, 0.30. Okay. All the incorrect ones, because
Sir,
incorrect ones we want to give more focus.
yeah.
Okay. And correct ones, since it's correct, we are not bothered much.
Yeah.
So your new weight is going to be this. Now, if you do the total here, okay.
Sir,
Total,
can you
yeah.
just tell once again how we got this new weight column?
Okay. So new weight column is old weight into amount of say.
Yeah.
Okay. And amount of say is this.
Okay.
Correct?
Yeah.
So amount of say is this. So e to the power of plus this will be for the incorrect ones, and minus this is going to be for correct ones. Okay, e to power of minus this into old weight.
Okay.
Minus, okay, of this value for the correct ones, and
Okay.
plus this value for the incorrect ones.
Okay, the sign of e power will be changing.
Sign of e power will be changing. Yes. Negative
Okay.
for the correct ones.
Okay, yeah, got it, sir.
Okay, not incorrect ones will have positive, so that it will have the higher weight.
Yeah.
The reason what I'm doing is, okay, and you will see after end of this step is, we have 8 unique values, isn't it? Now,
Yes.
if I take same set of values for the next step, you will get same answer, isn't it?
Yes,
See,
yes.
if because the steps are same, right? We will do same step and we'll get same Gini index. So if there's no change.
Yeah, I understood.
Okay.
Yeah.
So what we are saying is that, since this is incorrect, we will try to take more of this in the new set. Okay.
Okay.
We will try to take more of this and less of other ones. Okay, so this is a new weight. Now, if you do the total sum of this weight, it is 0.65. So typically the weight should be equal to 1. If you see this, because we did 1 by 8, right? So it
Yes,
should be equal to 1. So now we have to normalize this weight.
okay.
Normalize means total should be 1. Okay.
Okay.
So if you get 5 out of 65, okay, 5 out of 65, how much out of 100 did you get? So 5 by 65 into 100.
Yeah.
5 by 65 is marks you per one, I mean per one, how much marks you get per one mark, and then into 100. So same thing we are doing. So okay, so we will say here 0.05 divided by total. So this is 0.05 out of 0.65
Yeah.
into 1 for one value. So this is 0.7. Okay.
Not 7.
Okay. So this should.
So whatever
this-
values, new weight values we got, no sir,
Mhm.
0.05 and all.
Uh-huh.
Are they according to our data? I mean 0.84, sir.
Our data only, no.
Then correct only, no sir. The column he has given also, new weights are matching with ours.
No, new weight is 3.3, right? We got 3.0. That's what I was wondering.
Just a slight change because
That's
of.
what. No, it should not be slight change also. No, we are using same
Okay.
numbers, right?
Yes, sir. Yes.
So yeah, maybe what I'm, yeah, I don't know. That's okay. Okay.
Yeah. Yes, sir.
We are getting similar values. Yeah. But
Yeah.
I mean, more thing is you should know the importance of the steps.
Yes,
Okay.
sir. Yeah.
So once we do that, we have to first find the Gini index to know
Yeah.
which is, because when see whichever is doing correct is what we want to go ahead with. Okay. So Gini index will lower the index, higher the accuracy. So that's why we're going ahead with weight.
Yeah.
And in weight only one incorrect. So we got this higher value and rest will be smaller value. Okay. See,
Yes.
all these steps are being done to get maximum number of. Yes. Now, okay. So now you tell me, okay. Okay. You tell me random numbers between 0 and 1. Eight random numbers between 0 and 1. Dhanit, Karthik, tell me, keep telling me.
Any
Between
random numbers between 0 and what?
Yes, 0 and 1. Okay.
0.75, 0.54,
0.75, then
0.54.
Okay, try to make it more random. Okay, that means
Okay,
equally.
0.
Zero 0.69.
0.69. I'll give 0.056 something.
Okay.
0.1 also. 1 you have to.
Or no, sir. 8 done.
Oh, 8 done, right? Okay.
Yeah.
Now these are the random numbers. Okay. This is your normalized weight. Okay. Now we'll calculate cumulative. And cumulative, okay, first one will be this. Second one is going to be this plus this value, isn't it?
Yeah.
So 0.5. Okay, of course. Now you tell me 0.075 is where? Here, right? So 0.075. Then 54 is where? 54 is here.
Yeah.
Okay. So instead of highlighting, I will say 1 here, 1 here. Now 68 is where? Here only.
Yes.
This became 2. 32 is here only. 3. 18 is here. Okay. 43 is here only. Correct?
Yeah.
69 is here only. 06 is here. Okay. So now when you create this, okay, so this is 5 times, isn't it? So this data, okay, let's hide, we'll create this. Okay. Now this row, okay, will be taken 5 times. 1, 2, 3, 4, 5. Okay. This is being taken 1 time. So it's like this, when let's say, I give you the, questions to solve, you will decide to spend, you have 10 minutes, you will plan to spend 10 minutes on this problem, okay, which is incorrect one. You want to spend 10 minutes on this, okay, and rest, sorry, 5 minutes on this, rest 3 minutes, whatever, So you have 1 and you have 1. So this is 1. So yeah. So this is how, so this will be your data set for the next round. Because see, we are missing couple of things here. That's okay, because we anyway got them right, isn't it? Okay. And these
Hello, sir.
fives without,
Yeah.
yes.
Yeah.
So
Audible,
yeah,
sir.
so yeah, so these data has become your so this is your new data set. Okay. Now
Yes,
here
sir.
for second, now I have to start a second. So this first iteration is done.
Sir,
Based on
but these are random numbers. We have just randomly taken.
correct, randomly correct, taken, correct. But because see, because this has a more weight, this will appear more than once definitely.
Yeah.
See, each of these has a gap of 0.8, 0.08, 0.08, but this has more gap, isn't it?
Yes, sir.
Not here, this one, right? So you will be selecting this more time. Whether you select 4 times or 5 times or 6 times doesn't matter, right? You want to have more focus on this, want to spend more time on this.
Okay.
That's why you will end up getting this data set.
Okay.
Okay, since we got these wrong, okay, we want to focus more on these. Okay.
Okay.
So this is how training is done. Now again, you'll have equal weight 1 by 8, 1 by 8 for this. Okay. Now you find Gini index for each of the 3 and see which has minimum Gini index and create this kind of table. Okay.
Yeah.
So, okay. So this will keep on happening. Okay. Depending upon how many algorithms you run. So, but how does testing happens? Okay. The steps that you're doing is preserved. In the sense, in the first step, this is preserved. Okay. These two are not preserved. Okay. Because this give us more accurate result. So this is preserved. Okay. You will start with weight greater than 175. Okay. Then you will have yes, no. Okay. Now, similarly, you will have one more set, right? This will give some data, right?
Yeah.
So those steps are preserved. And when some testing happens, let's say, you get someone with no 200 kg. So you'll follow this path that is getting preserved. Okay. And then wherever you land, that is your, if you say ADA boosting of 1 step, right? Then you will stop here. And here it says that blocked artery and chest pain has no impact on heart disease. Only weight has impact on heart disease. Okay.
Because of its Gini index.
Yes, and we have taken only one algorithm, not multiple algorithm.
Yeah.
So if you run only once, this is what is preserved, right? So when you say no 200, based on 200, you'll say, okay, you'll have a heart problem. Okay, so all these steps are preserved, and when you give a new data, it follows the same path, and then it tells you, okay, what you have got is correct or not, or what should be the final output.
Okay.
So in ANA boosting, this is what we are boosting. We are boosting it, okay? The wrong thing we are boosting so that we can get it correct.
Yes, sir.
Right now, if you see, don't you think here these two will have more impact than this? Because 167 EY, the same values, isn't it? Okay. Now, okay, one of these will have more important than this. And thing which have missed, for that, weight is good enough.
I didn't get you, sir.
No, what I'm saying, those rows which we have missed here, okay, we have missed these. We have taken only 4 rows,
Once.
right?
Yeah, yeah.
Four rows are missed. So these 4 rows, okay, for it, weight is good enough.
Okay.
Okay.
Sir,
Hmm.
the bottom table, we have taken 5 times, right? 167 years.
Correct.
There actually, that is a wrong outcome, no, sir. Now,
No, why it is wrong outcome?
greater than 175? Actually, yes, no, sir.
Greater than 175?
Hard disk should be yes.
Where? Which row? Tell me the Excel row number.
First thing, sir, like weight when we are considering the
Tell me the row
constant.
number, no.
All this, sir, like
Which
28,
all these?
29, 30, 31,
28 to 29.
32. Yeah,
Right.
28 to.
28. No. We want to run it again. We want to run second model on this.
Okay.
We want to run it again. No, second time. Boosting means what?
Yeah.
Output that you are getting. The second person is solving the problem.
Okay.
See. Okay. Let's say you are solving the 8 problems. Okay. You are confident about 7 and you are not confident about this one only. For all the 7, you are confident.
Yeah.
So you're telling me, see, I got the out of 8 problems. This one I'm not sure, but rest 7 I've solved it. Correct?
Okay.
So you'll say, okay, no, I have only 8 minutes to solve, or 8 hours to solve, or 8 days to solve. Right? I'll say, okay, since you have not solved this, I will spend 5 hours on this.
Okay. So you're highlighting it more.
Yes.
Okay. Done.
That's what incorrect one you'll highlight. No.
Yeah. Yes, sir. Got it.
Okay.
Yes.
Now, if I send you, will you solve the problem which I'm confident or where I'm not confident?
Where you're not confident in the next step.
Yes.
Yeah.
So I'm giving 5 times the weightage.
Okay. Yes.
Now, it is done on random basis, just like this. Okay. Randomly, it will give some number and it will pick. Okay. It can come 3 times also. Okay. Or it can come 4 times also. Okay. That means I'm giving 4 times, 50% more weightage. Okay. Half of the time I'm going to spend on this problem only.
Yeah.
Because this problem is
The wrong
difficult.
one. Yes.
Yeah.
Yes.
Okay. But I will
Understood.
also verify other problems. I will not blindly trust you.
Okay.
Right?
Yes.
But since I have less time now, right? Out of 8, 5 hours is gone into it. I have only 3 hours. So I can only test 3 other things. So randomly I've taken 3 things, whichever 3, right?
Okay.
So randomly I've taken 3 because I want to focus more on this. Now, if this error was higher, okay, let's say if this error was not 7 by 8, it was higher error. That means let's say 5 by 8. Okay, 5 by 8 means what? This would have been 0.06. Okay, let's try to solve with that. Okay, 0.0606. No. Sorry, this is not the right place. This is where we need to do it, right?
Yeah.
So I'm increasing value. That means I want more probability of this one to be selected. 0.06, 0.0606, 06060606, and this will be minus of, right? So I'll remove this. 0.25. 0.25. Okay. So, okay. So it means what? Your confidence is gone down. See, you got only 1 out of 7. Now you're getting 2 out of 8 wrong. So your confidence is little down, little less down, right? So
Yeah.
now, okay, again, if you convert this, okay, this is good. Now cumulative is good. Now you see, let us delete it. Okay. So randomly 0.75. 0.75 is where? Here.
0.79.
Yeah, correct. Then 0.54.
0.61.
Here. Right? 68 is
0.70.
right. 32 is here.
52.
18
52.
is again here, right? 2.
Yeah.
0.43.
52.
Same here. 3, right?
69. 70.
Right? And
Not
0.06.
6. 1. First one.
Is it something
Okay.
wrong here?
Both are
No. Yeah.
0.15. No, sir. It should be. Second one should be
I think
0.15.
formula got wrong. Okay.
Yeah. One step ahead.
Yeah. So now again we have to do that.
Yeah.
So 0.75. 0.75 is here.
8 to 8. No, sir. Down.
Yeah, sorry. Here.
Mm.
0.54 is
No.
here.
No, 0.75 would be 0.73.
Correct. 73 is maximum number, right? 75 is more than 73, correct? Right.
We're going to the upper one.
6, 8. See, this is 73, right? 75 will be more than this, isn't it?
Yeah.
So it will fall in this. So this is 0 to 9 bucket. This is 0.9 to 0.18 bucket, 0.18 to 0.27 bucket, right? Now 3, 2.
Yeah.
3, 2 will
6, 4.
go here. Okay.
18.
18. 4, 3 will come here,
64. Yeah.
right? 69 will come
73.
here. Okay.
Not 6. First one.
0.06. Now you see.
Sir, they got the same answers.
No, not same answer. This is repeating only 3 times. Earlier it was repeating
Previously
5
5.
times.
Yeah. Previously 5.
Right? Now it
Yeah.
is repeating 3 times because your confidence is down. 2 wrong you got. Correct? Okay. And 2 wrong means probably these 2 are the wrong ones you would have got it. Okay. So these 2, so this is appearing 3 times, this is appearing 2 times, and rest is appearing 1 time. In fact, okay, see, mistake one step I missed was this 0.37 has to be for 2, right? Not for 1, correct? So which one did you get wrong? So let's say if I get wrong this one. So here also it should be 0.25, isn't it? 2 wrong. I said 2 wrong, correct?
Yes, sir. Yes, sir.
So 2 wrong will be 2 values will have 0.25.
Yeah.
Now if you do this, okay, so now you see these 2, okay, maybe you can try again then quickly. So here 0.75, here 0.54, here
There.
0.68,
There.
here 0.32.
So, sir,
Above.
Yes, tell me.
so for the first 3 ones, it's always the multiple of 1, 2, and 3.
Multiple of 1, 2, and 3. I didn't get you. Sorry.
Like when we had 9, it was 9 times 1 is 9, and then the second it was 18. The third one it was 27.
Which one you are saying?
For the first 3 on the cumulative.
You tell me row and column here. If you tell first one, second one, how will I know? There are so many cells here.
H 15, 16, and 17. H 15, 16, and
H
17.
15, 16, 17. Yeah, this is
like
same because we got same 0.07, right?
Yeah.
So if it had been something different, we would have got different also.
Okay, but
See, you will end up with 2 values, correct and
Okay.
incorrect. Incorrect will have higher than correct one.
right.
So that's why there's more probability that you will select incorrect ones for the next iteration. See, the whole
Okay.
logic here is, this is one step, okay? You can replace this step. So adapt boosting algorithm, which I'm going to talk about, does this logic.
Yeah.
Okay. So
Okay.
adapt boosting ADAPT boosting, and I've used 4 classifier, right? 4 times. I want to do 4 times.
Right.
Now
Right.
algorithm SAMME does what I'm doing it here. You can see this is the process of selecting. Okay, how do you select? Okay, obviously the ones that you got wrong has to selected more, isn't it? You can come
Right.
up with your own formula, and you can create a ADAPT boosting with different algorithm, Dwanit algorithm. Okay, the SAMME uses this algorithm to select the column for the next iteration.
Okay.
The one which are incorrect will have higher weights, and obviously
Okay.
will have higher chances of it getting selected for the next round. Okay, so now in next round, if you see, this row will come 4 times and this row will come 2 times.
Oh.
Okay,
Yep.
so because we want to focus more on these two. Now again you will find, okay, and then the third iteration you will tell, oh, I was able to find this correctly, but I could not find this. So next iteration, more focus will be on this problem.
Yeah.
Okay, so we are trying,
Yeah.
trying to find out. Okay, so there are 3 ways. You can't solve all the 3, right? We have to
Right.
follow one step. Okay, it's a step. Okay, it's not a decision tree. Decision tree will have multiple decision trees. Okay, one step, then second step below it, third step below it, third step, fourth below it. But you're using only one step. It is even more weaker algorithm. We are able to
Okay.
classify based on just one set, which is weight. Now weight
Okay.
is done. Okay, based on weight. Can you go on mute, Dhoni?
Yeah, sorry.
No problem. So we are trying to find out which are the columns which are getting which are incorrect, because we need to focus more on that column, and you keep repeating it multiple times. Okay, so now the next iteration, definitely weight will not be the one with Gini index. Something else might become, chest pain might become the this thing. So now we'll be using chest pain to see if that should be the one to be considered or not.
Okay.
Then again you run the same process. You select the most incorrect. Let's say out of these 8, you were able to classify 6 correctly based on chest pain. Next iteration, again you check with those 2 which got wrong. Okay, so we keep doing it, and the process is safely saved in the memory. So when you give a new value, okay, it follows the same step that we did here in step. Okay, so this is your ADAPT boosting. So
Yeah.
you try ADAPT boosting algorithm today.
Okay. So the system will do the whole thing, right?
Yeah, you don't have to do anything.
Yeah.
You just have to call ADAPT boosting. That's the thing.
Yes, sir. Okay. Okay, sir.
So we'll stop here today.
Yes, sir.
Okay.